All right, here we go. So now we're going to turn our attention, just like before, when we're dealing with systems of linear equations. Now we're going to turn our attention back to inconsistent systems and dependent equations. So first, we're going to look at identifying inconsistent systems. So here, just like before, when we're dealing with linear equations, right? Systems of linear equations, we talked about what an inconsistent system is, right? So that is one where we end up with a contradiction, right? We end up with something that is a false statement, and therefore letting us know that, hey, these lines or these planes do not intersect, okay? And so remember, parallel lines or parallel planes, right, would be the result, would be what we're looking at graphically when we look at inconsistent systems. So, so let's look at this example here. Okay, so what we're going to do is we're going to set up the matrix, right, the augmented matrix for this, right? So again, let's just draw it over here. So this would be 1, -3, -17, and then -59. And then 1, -2, -12, -41. And then we have, now the x is missing here, so that's 0, right? So -2, -10, and then 20, okay? So now what we're going to do is we're going to solve this using our EROs, right? Elementary row operations. So the first thing I'm going to do is I'm going to eliminate this 1, right? So I'm going to do negative row 1 plus row 2. Okay, and then I'm going to replace row 2. I'm running out of room here. Okay. So now let's do it over here. I'm going to just do the matrix here. So 1 and 3 are going to stay the same. So that's going to be 1, -3, -17, -59. And then the last row is 0, -2, -10, 20. And so what's going to happen to the second row? Well, we're going to do -1 plus 1, which is 0. We get 3 minus 2 is 1. And we get 17 plus -12 is 5. And then we get 59 plus -41 is going to give us 18. Right? Yep, 18. All right, so now here, let's get rid of, we've already got a 1 here, okay, in the second, in the next diagonal, right? So here we've got a 1, so let's eliminate the -2. So we're going to take 2 times row 2. So we're going to take 2 times row 2 plus row 3 and replace row 3, okay? And so now the first row is going to remain the same. Second row is going to remain the same. And let's do the last row. So now it's going to be 2 times row 2 plus row 3. So this would be 2 plus a -2, which is going to be 0. And then we're going to get 10 plus a -10, which is also 0. And then we get what? We get 36 plus 20. Yeah, 36 plus 20 is 56. And so if we look at the last row, right? So if we look at the last row, what does this tell us? This is telling us that we've got 0, right? This is saying 0 is equal to 56, which is not true, right? So that is a contradiction, which means that this is an inconsistent system. In this case here, we're talking about planes. Well, this is a line. This is a line in the YZ coordinate plane, right? So none of these intersect. Actually, no, this is a plane. This, you could look at this as a plane too, because this would be through the, so X is 0. So yeah, but this reduces to a line. Anyway, I'm digressing. But anyway, so the point being is that this is an inconsistent system, so none of these intersect, okay? So that's the takeaway. So what you're looking for is any time that you get a row of zeros over here with a constant over here, okay? Now, with a non-zero constant over here. Now, if you get a row of zeros, that's something else, okay? But if you get something where you've got a row of zeros and a non-zero constant over on this side, then you've got an inconsistent system.